During an internship for a museum, I offered the idea to use computer vision and machine learning techniques to prototype an idea about a cool tool that could be used by students of history to help them translate hieroglyph-based languages and murals and items. I wanted to build a predictive model that could be able to interpret a hieroglyph into its phoneme. I decided to use, for our predictive model, a neural network adapted for its use to images. In our current situation, our prototype must demonstrate our neural network's capacity to learn and adapt to our symbol interpretation problem. Depending upon the museum's satisfaction, the development of a full version could be decided. Some Egyptian hieroglyphs have been extracted, so we could have some data to work on. Later on, each hieroglyph will be labelized with its phoneme and fed to our predictive model so it could learn to identify and classify them. Now let's look at the structure of our neural network. This network has a 32x32 neurons input layer, a 16x16 neuron hidden layer, and 25 or more neurons output layer. The hieroglyphs are converted into binary images before being presented in input to our network. The Egyptian hieroglyphs being very distinct, the binary conversion still permits us to recognize them perfectly, while simplifying the learning process for the network. The neurons in the hidden layer are connected to local patches of neurons on the input layer. This is closer to the biological design how neurons interact in our visual systems. The network will be fed a training set of the hieroglyph. After training, the neural network should be ready to start recognizing the symbols it has been trained on. One of the factors of a neural network's efficiency is the size and variety of its training set. Let's have a look at the training process. This is the beginning of the training process. Notice that the outputs are at random values and the network makes mistakes, in red, at its first tries. Let's continue the training process. Each training pass increases the network's efficiency. Each time you see a red command on the left, the network makes a mistake and guesses right when the command is in green. Notice how, as the training progresses, there are more and more successful guesses. At the end of the training process, the trained cases are correctly recognized. Notice the output cases being close to 1 or -1. This indicates the network certainty. This means the model has successfully been trained. Now let's check its efficiency with a collection of test cases. The test cases, extracted from pictures of murals that you can see on the left, are being fed to the model at once. Let's see what our predictive model thinks they are. This picture, 21.bmp, has successfully been identified as the phoneme un, symbolized by a chick. This one is ez, the scepter. Overall, on this test set, the identification success rate is approximately 75%. The neural network, at this early experimental stage, has been trained with just 25 hieroglyphs and is giving satisfactory results, as well as good scalability prospects. Now that we tested it with a set of real hieroglyphs, let's try something else with our network. Let's draw some doodle hieroglyphs by hand and see how well it is able to recognize them. Here you can see me drawing by mouse a few hieroglyphs on GIMP. Notice I am not the best artist. I have seen them quite a few times, so let's say they look like that, more or less. The Czech hieroglyph has successfully been identified despite the approximate drawing that can be seen in the bottom left. As for the Lutz hieroglyph and the Hunks, some of them are incorrectly recognized. This is as much of a lack of training data factor as my poor drawing skills. Later on, this technology could be used by the professionals of history to help their translation process. And I hope a finished product could even be used by tourists to have a richer and interactive experience when visiting ancient sites directly with the help of their phones. A complete product will represent a very difficult challenge and probably months or even years of development. Such product would include proper extraction of the hieroglyphs from the image, accurate prediction of each symbol, then finally, running the translated phonemes into a dictionary to obtain a proper translation.